Imagining a world where animals are attracted not by sight, but by artificial intelligence. Sounds futuristic, right? However, this technology poses urgent risks that could mislead us in critical ways. Many believe age-driven pose estimation is the key to understanding wildlife behavior, but beneath this shiny exterior lays a troubling truth. What if the data we rely on to protect endangered species is riddled with inaccuracies? Picture a majestic elephant roaming the savanna. Researchers analyze its movements using cameras and algorithms, but what if pose estimation fails to accurately capture its stress signals? The consequences could be dire. You might wonder, how could this happen? Systems are trained on specific datasets, and if those datasets are flawed, the technology may misinterpret the animal's emotions. A flick of an ear or a shift in stance of these subtle signals could easily be misunderstood. Now, imagine that same elephant being pushed to its limits without anyone realizing it. Wildlife conservationists depend on this technology for critical decisions. If A mistakenly identifies a stressed animal as calm, they might overlook the urgent need for intervention. It's a ticking time bomb, and we're the ones holding the match. Moreover, relying on this technology could create a false sense of security. With each error, we risk making decisions based on a distorted view. Reality. Imagine investing time and resources into protecting a habitat, only to discover later that the data was misleading. As we navigate this technological landscape, we must confront the limitations of A. Remember, technology is only as reliable as the people behind it. So, what can we do? It's crucial to combine A insights with human observation. Field researchers need to stay grounded, interpreting what algorithms can't see. This hybrid approach could lead to more accurate assessments, ensuring our efforts to protect wildlife are based in reality. In a world where technology promises everything, we must remember it's not infallible. As we push the boundaries of innovation, let's question what's hidden beneath the surface. The next time you hear about A in wildlife monitoring, consider the pose estimation warning signs lurking just out of sight. In this delicate balance of technology and nature, every signal counts. What if I told you that the technology we rely on to monitor wildlife might not be giving us the full picture? Imagining a stunning elephant wandering the savanna, perfectly captured on camera. But what if the data we receive is completely inaccurate? This isn't just a minor concern, it's an issue many people haven't considered. While A-driven pose estimation is often seen as a game changer for conservation, there are hidden inaccuracies we need to address. This problem is quietly growing, and most of us remain blissfully unknowing why it's so old. The implications are serious and the stakes are higher than you might think. Picture yourself in a lush forest, eager to catch a glimpse of a rare bird. You've set up your cameras, trusting the AI to track its movements accurately. But what if that AI misjudges the bird's pose or fails to locate it altogether? These inaccuracies can lead to incorrect population counts, misreported behaviors, and misguided conservation efforts. The technology might indicate that a species is thriving, while in reality, it could be on the brink of extinction. Can you imagine the weight of that possibility? Now think about a researcher in the field, spending weeks collecting data, believing they are making a difference. Yet, every decision they make is based on flawed information. It's a heartbreaking scenario that could jeopardize entire ecosystems. Furthermore, these inaccuracies can create a false sense of security, leading organizations to allocate resources where they aren't needed. Imagine funding a project to save a population that no longer exists. It's a chilling thought, isn't it? As a technology advances, so do the methods for pose estimation. However, the algorithms often struggle to adapt to different species or environments. What works for one animal may not work for another. Can you see the cracks forming in our trust in this technology? So, what can we do? While technology offers benefits, we need to advocate for human oversight. Imagine researchers collaborating with AI, double-checking data before making crucial conservation decisions. That's a partnership worth fostering. Reflecting on this, it's clear that the hidden inaccuracies of AI-driven pose estimation affect not just wildlife, but the very fabric of our environment. We must stay informed and demand transparency in the technologies we depend on. In a world increasingly influenced by AI, let's remember that technology should enhance our understanding, not obscure it. Stay curious, question everything, and help protect the precious wildlife we cherish. After all, the future is in our hands. Imagine you're deep in a vast forest, watching a majestic deer glide gracefully through the trees. But what if I told you that the technology helping researchers track this beautiful creature has some serious flaws? Right now, AI-driven pose estimation is revolutionizing wildlife monitoring, yet many overlook a critical aspect: accuracy issues that could significantly affect our understanding of animal behavior. Surprised? You're not alone. Most people don't realize just how significant these inaccuracies can be. Picture this: a team of scientists eagerly analyzing data, convinced they've captured the perfect movements of a rare species. Yet, hidden discrepancies in the AI's estimations can lead to misleading conclusions. It's like reading a book while missing entire chapters. The algorithms, while advanced, have limitations. They often struggle with variations in lighting, terrain, and even the natural behaviors of animals. Imagine watching a video of a bird in flight, only to find the AI misinterprets its wings as something entirely different. This isn't just a technical issue, it has real-world consequences. For conservationists, these inaccuracies could lead to misallocating resources to protect areas that aren't even critical habitats. The stakes are incredibly high. Now, let's return to you in that forest. You might trust the data you are seeing, but what if it's leading you to misunderstand the animal's patterns? You could be observing the wrong